Welcome to another deep dive. We're going to be talking about compressors today.
Oh, yeah, compressors.
Yeah. Now, you might just be thinking about like the thing that you use to, put air in your car tires.
Yeah, right.
But there's actually like a whole universe of different types of compressors. And what they all have in common is they increase the pressure of a gas or vapor.
Yes.
And our mission today is to get a handle on the main types and some of their intricacies. And luckily, you provided us with a bunch of documents that will help us do just that.
Yeah, you provided us with a great set of API standards.
NPN?
And so API standards are basically industry-wide guidelines to make sure that equipment like compressors are designed and operate in a safe and consistent manner.
Right.
So this is really important for safety and reliability in these industrial applications.
Oh, yeah.
And the documents you provided cover various classifications of these compressors. There are helpful diagrams, descriptions of the different types, and it really highlights how important compressors are in a variety of industries.
Yeah.
From really massive applications like oil and gas to even, things like your refrigerator.
Yeah.
They use a compressor.
Okay. So let's start by looking at, the first main breakdown.
Yeah.
Like when you're talking about a compressor, you have to decide, are we talking about a kinetic compressor or a positive displacement compressor?
Right.
So with a kinetic compressor, you're basically using motion to speed up the gas.
Right. Yep.
And then that speed is converted into pressure.
Yes.
And the main categories there are centrifugal and axial.
Correct.
With a positive displacement compressor,
Uh-huh.
you're actually crapping a specific volume of gas.
Yeah.
And then you're squeezing it down into a smaller volume to increase the pressure.
Right.
And that includes reciprocating compressors.
Yes.
And rotary compressors and rotor compressors have all these subtypes like screw lobe, sliding vane, and gear.
Yes. And that's just a general overview of the two main types. And if you look at the main types of compressors table you've provided in your documents, it really highlights some of the key differences and the comparison points between these main categories.
Okay.
Like, for example, positive displacement compressors are capable of achieving very, very high pressures,
Yeah.
but they typically handle smaller volumes of gas.
Right.
Whereas centrifugal and axial compressors, those are kinetic types. They operate at lower pressures generally, but they're capable of moving very, very large quantities of gas. And actually, actual flow compressors are specifically built for those very high flow rate applications.
Okay. And I see here on this table we have a column called specific rated value, or SRV.
Right.
And it says NO for positive displacement
Yes.
and YesRES for centrifugal and axial.
Right.
So what is that telling us?
So SRV essentially it highlights whether the compressor's peak performance is very tightly coupled to a very specific operating point or a design sweet spot. And so for centrifugal and axial compressors, which are very dynamic machines with spinning components, things like the specific speed of the impeller are very important for understanding the efficiency and how well it performs under different conditions.
Got it.
Whereas positive displacement compressors, the way that they increase pressure is much more directly tied to the mechanical reduction in volume.
Right.
So they aren't typically characterized using that same kind of specific rated value.
Okay.
But it is an important consideration when you're selecting a compressor for a specific application, because if you have a very tight operating range and you need to stay within that range, a centrifugal or axial compressor might be a better choice. But if you have a broader range of operating conditions, then positive displacement compressor might be more suitable.
And this table also points out some other, important distinctions. Like positive displacement compressors tend to have high efficiency but high maintenance costs, and they produce a pulsating flow.
Yes, that's correct.
Whereas centrifugal and axial, generally lower maintenance, smoother flow, but centrifugals can experience surging.
Right.
We were going to talk about.
Mm-hmm.
And axial share that characteristic.
Yes.
And then in terms of efficiency, positive displacement, high centrifugal low, and axial flow very high.
Correct.
So it sounds like, choosing the right compressor is all about the trade-offs.
Absolutely.
Based on what you need it to do.
Yeah.
All right, so let's zoom in and take a closer look at some of these, starting with centrifugal compressors.
All right.
So some of the advantages of centrifugal compressors I see here is that they have a wide operating range, which is nice.
Yes.
Low maintenance, high reliability, high-speed capability, and higher flow for a given size.
Yeah, that's right. Centrifugal compressors have some very compelling advantages, and that's why they're used so extensively in various industries. They do have a wide operating range, which gives you a lot of flexibility.
Yeah.
They are typically low maintenance, and very reliable.
Right.
And they can spin at really high speeds, and for given size, they can move more gas compared to some other designs.
Okay.
So those are some of the big advantages.
But there are some disadvantages too.
There are some disadvantages.
Unstable at low flow, moderate efficiency, and low pressure ratio per stage.
Right. So while they do have their advantages, it's important to keep in mind some of the disadvantages as well.
Okay.
So one of the downsides is they can become unstable if the flow rate drops too low.
Got it.
Generally, their efficiency is moderate compared to something like an axial compressor.
Right.
And they typically don't increase the pressure as much per stage as other types.
Right.
So you often have to link multiple stages together to get higher pressures.
Okay.
But overall, they are very widely used and have a lot of applications.
Okay. And then moving on to axial compressors.
Yeah.
Some of the things that jumped out at me were that they have high efficiency.
Right.
They can move a lot of gas relative to their size.
Yes.
And they operate at lower pressure.
Yes.
So,
So axial compressors are really good for situations where you need very high flow rates and high efficiency. That's why they're often used in gas turbines, for example.
right.
But they do have some drawbacks as well.
Yeah.
They have a narrower range of flow rates where they operate efficiently compared to centrifugals.
Got it.
Their blades are quite delicate and expensive, so they can be more susceptible to damage.
Right.
And they also share that characteristic of a lower pressure increase per stage.
Okay.
So you often have to use multiple stages to achieve higher pressures.
Okay.
But they are very good at what they do.
Okay. Now, this one document mentions that efficiency tends to increase as specific speed increases,
Right.
reaching up to 90% for both centrifugal and axial compressors.
Right.
So what is specific speed?
When engineers talk about kinetic compressors, you might hear the term specific speed or ENS.
Okay.
And that's basically a way to categorize the shape of the impeller
Okay.
based on how it best handles flow and pressure. And so as you increase the specific speed, generally the efficiency of the compressor will also increase.
Yeah.
And there's a point where it kind of peaks out and then starts to decline again.
Yeah.
But generally, higher specific speed means higher efficiency.
Okay. This document also mentions multi-stage compressors, and it mentions that they have impellers in a row for both types.
Right?
And then it mentions this kind of clever design of opposite impellers in multi-stage centrifugal compressors.
Yeah.
So-
So the reason for putting impellers in a row or in series is to achieve higher pressure increases.
Okay.
So each stage essentially adds to the pressure built by the previous stage.
Got it.
And then using opposite impellers in multi-stage centrifugal compressors, that's a clever bit of engineering to counteract the axial thrust forces
Right.
that are generated during operation.
Okay.
So it reduces stress on the bearings
Yeah.
and improves the stability and longevity of the machine.
Okay, so that's a smart way to reduce those forces. All right. And then there's a section here about split-type compressor casings,
Right.
which talks about horizontally split casings, which are used for high flow and medium pressure,
Right.
and vertically split casings, which are also known as double barrel, for high pressure, medium flow.
Yes.
So why the different designs?
So the reason for the different designs is largely due to the operating pressures.
Okay.
So horizontally split casings are generally easier to open up for maintenance,
Right.
and they're suitable for lower to medium pressure applications.
Okay.
But when you're dealing with very high pressures, a vertically split or a barrel type casing offers superior containment.
Yeah.
And the structural strength needed to withstand those higher forces.
Okay. So it's really all about the pressures involved.
Yeah.
Okay. Let's go back to axial flow compressors for a second.
Okay.
One of your documents specifies that they're governed by API 617,
Right.
which are those industry-wide guidelines we were talking about. And it reiterates that they have very high flow rate, low pressure, and very high efficiency.
Yes.
And then it lists a bunch of components, like the inlet rotor, stationary aerodynamics,
Right.
discharge cover thrust, bearing journal, bearing dry gas seal casing, shear ring balance piston.
Yeah.
Is there anything, noteworthy there?
Yeah, absolutely. So the list of components there really highlights the sophisticated nature of axial flow compressors.
Okay.
And when we talk about stationary aerodynamics, those are essentially fixed blades or guide vanes that help to direct the airflow between the spinning rotor blades
Right.
and optimize the pressure increase and the overall efficiency.
Okay.
And then the fact that you see things like dry gas seals and thrust bearings
Yeah.
really highlights the need for advanced sealing technologies
Right.
and robust bearing systems to handle those incredibly incredibly high speeds
Yeah.
and flow rates.
All right. So we've looked at the kinetic compressors.
Right.
And now let's move on to positive displacement,
Okay.
starting with reciprocating compressors.
Right.
So your documents mention that they're governed by API 618.
Yes,
They have low flow rate, high pressure, moderate efficiency.
that's correct.
So quite a contrast from what we were just talking about.
Yeah, it's a fundamental shift in how the compression is achieved.
Okay.
So reciprocating compressors operate on a completely different principle.
Okay.
They use a piston moving back and forth inside a cylinder,
Okay.
and the piston draws in gas on one stroke
Right.
and then compresses it on the return stroke.
Got it.
And this mechanical action allows them to generate those very high pressures.
Yeah.
But the inherent back and forth motion limits how fast they can operate,
Right.
and therefore the volume of gas that they can move.
Okay.
So that's why they're typically used for lower flow rate applications.
Okay. It also lists some of their key properties here. Lower power density,
Right.
lower speed, 300 to 1800 RPM, generally used in low volumetric rate applications, less than 500 ACFM,
Yes.
or 850 cubic meters per hour. Higher maintenance, unaffected by changes in gas properties like molecular weight or temperature.
Correct.
So that last one seems significant.
Yeah, that's a major advantage of reciprocating compressors.
Okay.
Unlike kinetic compressors, whose performance is very dependent on the properties of the gas they're handling,
Right.
reciprocating compressors really rely on the physical displacement of that piston.
Yeah.
So that makes them really good for handling a wide variety of gases under different conditions.
Okay.
But there are those trade-offs like higher maintenance.
Yeah.
The pulsating flow. They tend to have a higher weight to capacity ratio,
Yeah.
and they require bigger foundations because of the vibrations.
Okay. And it lists a bunch of components: crosshead stuffing box, discharge valves, suction valves, piston distance PC, conrod, crank, piston rod wiper.
Right.
It's a pretty long list.
Yeah, it sounds almost like a miniature internal combustion engine in some respects.
Right.
So all those components play a very important role in the operation of the compressor.
Okay.
The crosshead
Yeah.
and the connecting rod mechanism, that's what translates the rotary motion of the crankshaft into the linear back and forth motion of the piston.
Right.
The stuffing box, that's a very critical seal to prevent gas from leaking out around the piston rod.
Yeah.
And then you have the suction and discharge valves, which control when gas enters and leaves the cylinder during each cycle.
Right.
So all those components are very important.
Okay. Then it talks about multi-stage reciprocating compressors.
Yes.
And it mentions accumulators and pulsation dampeners and interstage coolers and scrubbers.
Right.
So what is the purpose of all that?
So similar to kinetic compressors, using multiple stages in a reciprocating compressor is a more efficient way to achieve very high pressure increases.
Okay.
The interstage coolers play a very important role in reducing the temperature of the gas between the compression stages.
Okay.
And that reduces the power required for the subsequent compression.
Right.
And then you have the scrubbers, which are used to remove any liquids or contaminants that might condense out of the gas stream.
Okay.
And then you have the accumulators and the pulsation dampeners,
Right.
which are used to smooth out that inherent pulsating flow that you get from a reciprocating compressor.
Yeah.
And that helps to minimize vibrations
Okay.
and potential damage to other equipment in the system.
So that's really important. Now, how do you control the flow rate in a reciprocating compressor?
Right.
It mentions a few methods starting with variable clearance.
Yes.
Both manual and pneumatic.
Correct.
So how does that work?
So variable clearance is a very clever way to adjust the output of the compressor without having to change the speed.
Okay.
And so by increasing the clearance volume in the cylinder head,
Right.
which is the space above the piston when it reaches the top of its stroke,
Yeah.
you effectively reduce the amount of gas
Got it.
that's drawn in and compressed during each cycle. And the documents even provide some diagrams and formulas that illustrate the relationship between the clearance volume
Right.
and the volumetric efficiency, which directly impacts the flow rate.
Okay.
And interestingly, changing the clearance mainly impacts the flow
Yeah.
and doesn't significantly alter the discharge pressure.
Okay.
So that's an important consideration as well.
So it's like you're creating this extra space in the cylinder.
Yeah, you're essentially creating a little bit of dead space
Right.
in the cylinder to reduce the amount of gas that's being compressed.
Okay. And then it mentions suction valve unloaders.
Right.
How do those work?
So suction valve unloaders are another method to reduce the capacity of the compressor.
Okay.
And typically this is done in steps.
Got it.
So they're basically mechanisms that can hold one or more of the suction valves open
Okay.
during part or all of the compression stroke.
Okay.
So if you have a compressor with 4 suction valves, for example,
Yeah.
if you activate the unloader on one of those valves,
Yeah. It would prevent gas from being drawn in through that valve
okay,
and effectively reduce the capacity by about 25%.
right.
And if you unloaded all 4, you would get essentially zero flow.
Okay, so it's like turning off a cylinder in an engine.
Yeah, it's very similar to that. It's
Oh.
like selectively disabling individual cylinders.
Okay. And then other methods it mentions are variable speed,
Right.
bypass, and periodic shutdown.
Correct.
So those are pretty self-explanatory.
Yeah.
You know, variable speed, you just change the speed.
Yes.
Bypass, you're routing some of the gas back to the intake side.
Correct.
And periodic shutdown, you're just turning it off.
Yep.
When you don't need it.
Right.
All right. So that's reciprocating compressors.
Yes.
Now let's look at rotary compressors.
Okay.
The first thing it mentions here is a relief valve.
Right.
And I'm assuming that's like a safety thing to make sure the pressure doesn't get too high.
That's exactly right.
Oh, a relief valve is a very important safety device on pretty much any compressor system.
Right.
And it's designed to automatically vent excess pressure if the system exceeds its safe operating limits.
Right.
And that prevents potential damage or failure.
Yeah.
So it's a very important safety feature.
Okay. Then it goes into rotary screw compressors,
Yes.
which
Yeah.
have these subtypes of dry screw and oil-flooded screw.
Correct.
So what's the difference there?
The main difference is whether oil is injected into the compression chamber
Okay.
as the rotors turn.
Got it.
So in an oil-flooded screw compressor,
Yeah.
oil is injected to help with cooling,
Okay.
to create a tighter seal between the rotors,
Yeah.
and to provide lubrication.
Right.
And that allows them to achieve higher pressure ratios
Okay.
and better efficiencies in a single stage.
Got it.
Whereas dry screw compressors operate without any oil in the compression chamber.
Okay.
So they're typically used for applications where oil contamination is a concern, such as food processing or pharmaceuticals.
Got it. And then it mentions a rotor profile with a 4-lobe male rotor and a 6-lobe female rotor.
Right.
That sounds like it's a...
It is. It requires some very precise manufacturing.
Yeah?
The shape of the rotors
Yeah.
and the way they mesh together is very critical
Right.
for trapping the gas and reducing its volume
Okay.
as it moves along the screws.
Okay, and this oil flooding system, it's not just about lubrication, it's also about cooling and sealing.
That's right.
So the oil's really doing triple duty there.
Yeah.
And then it talks about multiple double end arrangements.
Right.
So what's the advantage of that?
So a double end arrangement basically means you have 2 sets of screw rotors
Okay.
mounted on a single motor or gearbox.
Okay.
And that allows you to achieve much higher flow rates
Right.
from a single unit.
Got it.
So it's a way to increase the capacity
Okay.
without having to make the individual rotors larger.
Okay. Then it talks about dry helical screw compressors. Yes. Which are driven by external timing gears.
Correct.
And there's no contact between the rotors.
Right.
So if they're not touching, why are the timing gears so important?
So the timing gears in a dry screw compressor are very important because their job is to synchronize the rotation
Okay.
of the 2 rotors
Right.
so that they maintain a very small gap, but they never actually touch each other.
Yeah.
And this is important because there's no oil in the compression chamber
Right.
to provide lubrication.
Right.
So if the rotors were to touch, it would cause wear and tear
Got it.
and potential damage.
So the gears are what keep them separate.
Exactly.
Okay.
It also briefly mentions rotary vane compressors,
Right.
and it touches on other rotary types like 2-lobe and 3-lobe compressors.
Yes.
And it mentions external and internal gear arrangements.
Correct.
So it sounds like there's all these different types.
Yeah, the rotary compressor category is quite diverse.
Yeah.
There's a lot of different designs
Okay.
for different applications. All right. So now let's talk about surge,
Okay.
which is this phenomenon that can happen with
With centrifugal and axial compressors.
centrifugal and axial, right, not reciprocating.
Correct.
So what exactly is surge?
So surge is a potentially damaging condition that can occur in centrifugal and axial compressors.
Okay.
And it's basically a flow reversal.
Okay.
So the gas that's being compressed
Yeah.
flows backwards from the discharge side of the compressor
Got it.
back towards the suction,
Okay.
and then it flows forward again.
Right.
And this cycle can repeat very rapidly
Yeah.
and cause significant pressure and flow oscillations.
Okay.
So it's not a good thing.
Not a good thing. So what causes it?
There are a number of factors that can contribute to surge.
Okay.
One of the main causes is insufficient flow rate through the compressor.
Okay.
So if the demand for compressed gas drops too low,
Right.
the compressor can enter a region of unstable operation. Changes in the properties of the gas being compressed, like its density,
Yeah.
can also play a role.
Okay.
And then the shape of the compressor's performance curve.
Okay.
If the pressure doesn't increase much as the flow rate decreases,
Right.
that can also make it more susceptible to surge.
Okay.
So there are a number of factors that can contribute to it.
Okay. And your document points out that surge can happen during normal operation, but it can also happen during startup and shutdown and other abnormal conditions.
That's right.
So it's not just something that happens when it's running normally.
Yeah.
It can happen during those transients as well.
Correct.
And then there's this distinction made between the way gases and liquids behave under pressure.
Right.
It mentions that gas is compressible while liquid is not.
Correct.
So how does that relate to surge?
So because gases are compressible, they can store a significant amount of energy when they're compressed.
Right.
And in centrifugal and axial compressors, which are continuously moving gas. Yeah.
If the pressure downstream is too high,
Right.
or the flow rate is too low,
Yeah.
the energy stored in that compressed gas can actually overcome the compressor's ability to keep pushing it forward.
Got it.
And that leads to the backflow.
Okay.
Liquids, on the other hand, are essentially incompressible.
Right.
So they don't exhibit that same kind of behavior.
Okay.
And reciprocating compressors with their distinct intake and discharge strokes,
Yeah.
they also handle the pressure buildup differently.
Okay.
So they don't experience surge in the same way
Okay.
that centrifugal and axial compressors do.
Okay. And the document makes a good point that the energy level of that gas is similar across a certain range of low flow,
Right.
which contributes to the instability.
Yeah, that's a very important point.
Okay.
The pressure energy curve for a centrifugal compressor is relatively flat
Okay.
at low flow rates.
Right.
And that means that the gas has a similar energy level over a certain range of flow.
Yeah.
And that can contribute to instability. Okay, so if the flow rate is sufficient, then you avoid surge.
Correct.
But if it's not,
Yeah.
then it starts this cycling, which can be as fast as 5 to 20 cycles per second.
Right.
And that's a lot of stress on the components.
Yes. And the document explicitly mentions the damaging effects of surge on centrifugal compressors.
Yeah.
Specifically highlighting the thrust bearings which handle the axial forces
Right.
and the rotor itself.
Yeah.
So the repeated reversals of flow and pressure
Yeah.
can cause significant damage.
So it's really something you want to avoid.
Absolutely.
So how do you prevent surge?
So there are a number of anti-surge methods that are commonly used.
Okay.
One of the most common and effective methods is to use a bypass line with an anti-surge valve.
Okay.
And so this bypass line allows some of the compressed gas to be routed back to the compressor inlet.
Okay.
And the anti-surge valve will automatically open if the system detects
Yeah.
that the compressor is approaching its surge limit. And typically this is done using a sophisticated anti-surge integrated controller, or UIC.
Right.
And so the purpose of the bypass line is to increase the flow rate through the compressor
Okay.
and move its operating point away from that unstable surge region.
Okay.
And the document even provides a helpful diagram to illustrate this.
Yeah, and it shows that the bypassed gas goes through a cooler before it goes back to the compressor inlet.
Right.
Why is that?
So that's a very important point.
Yeah.
Compressing gas increases its temperature.
Right.
And if you were to continuously recycle that hot compressed gas back to the inlet
Yeah.
without cooling it,
Yeah.
it would lead to a gradual increase in the inlet temperature,
Okay.
which would negatively impact the efficiency of the compressor
Got it.
and potentially even exceed its safe operating limits.
Okay.
So the cooler in the bypass line helps to dissipate that heat
Right.
and ensure that the gas going back to the compressor
Right.
is at a manageable temperature.
Okay.
Yeah.
And it mentions a reliable trip line and a surge control line on this graph.
Right.
What are those?
So those lines on the graph, which typically plots the pressure rise versus the flow rate,
Yeah.
define the safe operating envelope of the machine.
Okay.
So the surge limit line represents the absolute boundary
Right.
beyond which surge is likely to occur.
Okay.
The surge control line is set to the right of the surge limit line.
Right.
And the